So guys, now let us go through the example in which we will going to discuss how route can be deleted from the mtry data structure. So you can see that this is the mtry data structure which is already built, because at this point of time these 6 routes have been inserted into this mtry data structure. Alright, so now let us delete each of these routes one by one, starting with the first route. So we want to delete a route 1.2.3.4/32 from this mtry data structure. So the very first thing again we will do is to compute the effective prefix of this route. Alright, and now let us go through the steps regarding route deletion. So the very first thing that we need to do is that execute the route search algorithm and locate the leaf node which stores the data for this route 1.2.3.4/32. So the exact match route search algorithm will going to give us the node number 9. Alright, after having located such a node, simply delete that node. So the node number 9 is deleted straight away. Alright, so obviously in the parent node you will adjust the pointer value to point it to null because the child has been deleted. Now you can see that the node number 2 is a half node. It is a node which has exactly one child, and that is now node number 10. So now we need to fix up our mtry such that the node number 2 becomes the full node. That is the node with exactly 2 children or the node with exactly 0 children. The node number 2 cannot continue to exist as a half node. So the following step is the node merging algorithm. So let us execute these steps one by one. The very first step says that append the effective prefix of the other child, which is the node 10. So node 9 parents is node 2 and node 2's other child is node 10. Alright, so append the effective prefix of the node 10 to the effective prefix of the node 2. The effective prefix of the node 10 contains don't care, which is 24 times don't care bits. So the effective prefix of the node 2 would become the effective prefix which it already has, appended by the effective prefix of the node 10, which is 24 times don't care. And obviously, since you are merging 24 don't care bits to the effective prefix of the node 2, therefore the prefix length of the node 2 would become 8 plus 24, which is 32. Alright, so the effective prefix of the node 2 is 7 times 0, then 1, and then 24 times don't care bits. Then the second step is that transfer the data of the node 10 to the node 2. So here the node 10 has the data which is next hop 1.0.0.0/8, that is pointer to some object in the memory which represent the next hop. So simply transfer this data to the parent, which is node 2. So the data part of the node 2 would become next hop 1.0.0.0/8. That is the next hop of the route 1.0.0.0/8 has been moved from the node 10 to the node 2. Then the next step says break the parent-child relationship between the node 2 and the node 10. That is, this linkage will going to be broken. So node 2's don't care children would become null. Alright, and the next step says that transfer all the children of the node 10 to the node 2. So in this case the node 10 is a leaf node, it do not have any children, therefore there will be no transfer of any children of the node 10 to the node 2. But if node 10 had any children, then they would have been moved as a children to the node 2. And finally delete the node 10 as well. So it will take you a couple of 2-3 times a practice to actually exercise this route deletion algorithm. So don't worry, we will going to delete all these routes one by one from this mtry data structure. So now you must be very eager to see what does the final mtry data structure look like when the route 1.2.3.4 has been deleted from this mtry data structure. So you can see that deletion of a route from the M-trie result in the deletion of two nodes from the M-trie data structure. In this case, the node number 9 and the node number 10. So the final M-trie data structure would look something like this. Alright, you can see that the effective prefix of the node 2 is now grew from just prefix length 8 to full prefix length 32, because this portion of the effective prefix is coming from the node number 10, which has been merged into the node 2. So again, let us take one more example. Let us delete the route 128.2.3.4/32. So convert the route that is to be deleted into its effective prefix form. Alright, and now execute the exact match route search algorithm, and you will find that the node number 5 is the node which we are willing to delete. It is the node which holds the next hop for the route which is being deleted. So we are interested in deleting the node number 5. So straight away delete the node number 5, adjust the pointer of the parent node to point it to null because its child has been deleted. And now the node number 7 has become a half node, therefore node number 7 will execute the merge algorithm. Alright, so again these steps will be executed. You append the prefix of the node 6 to the effective prefix of the node 7. So node 7 effective prefix would become XXXX 16 times, and the prefix length of the node 7 would become 24, because 16 don't care bits has been transferred to the node 7. Then transfer the data of the node 6 to the data of the node 7. Alright, so the data part of the node 6 would become null. Then break the parent-child relationship between the node 7 and the node 6. So the node 7 pointer needs to be adjusted to point it to null. Now transfer all the children of the node 6 to node 7. So in this case again, node 6 is a leaf node, therefore there is no need to transfer any children of the node 6 to the node 7, and finally delete the node 6. Alright, so the final M-trie data structure would be this one. Alright, the node number 5 and the node number 6 has been completely disappeared from this M-trie data structure. Now let us go through the next example. So proceeding towards the next example, let us delete the route number 3, which is a default route. So execute the exact match route search algorithm, and you will find that you need to delete the node number 4. Alright, now it is an exceptional case that whenever you need to delete a node which is a direct child of the root node, then you have to do nothing, simply delete that particular node from the M-trie data structure and adjust the parent and adjust the child pointer of the parent node to point it to null. Alright, so the final M-trie data structure would look something like this. The node number 4 has simply disappeared from this M-trie data structure. Alright, the root node never execute merge algorithm. Remember that. There is no need for the root node to execute any merge algorithm. A root node can be half node, it can have one child, it can have two children, it can have three children. A root node enjoys all the privileges. So guys, now you can see our M-trie data structure is gradually shrinking. Now let us continue with the route deletion. Now let us delete the route number 4, which is 128.2.0.0/16. So the effective prefix of this route would be the following. Alright, so using exact match route search algorithm, we would going to locate the node, which is the node number 7, which holds the data for this route 128.2.0.0/16. And as per the algorithm, we will going to delete the node number 7 straight away, and its parent, that is node number 3, would become a half node, so it will execute the merge algorithm. Alright, After executing the merge algorithm, the node number 8 would be vanished and node number 3 will borrow the effective prefixes of the node 8 such that the node number 3 would have the effective prefix of length 32. The data part has also borrowed from the node 8 which has just vanished. Also, the node number 8 which is just deleted did not have any children. Therefore, there is no transfer of any children from the node 8 to the node 3 and the node 3 becomes a new leaf node. So this completes the deletion of the route number 4. Then coming to the route number 5, compute the effective prefix of the route 5 and trigger the route search exact match algorithm which would give you the node number 3. Alright, and now we will simply going to delete the node number 3, and since the parent of the node 3 is a root, therefore there is no need to execute merge algorithm. So the final entry data structure would be the following. As simple as that. And this completes the deletion of the route number 5. Now let us delete the final route. So compute the effective prefix of this route and trigger the exact match route search algorithm which would going to give you the node number 2. Alright, so delete the node number 2, and since the parent is a root, therefore there is no need to execute any merging algorithm, and the final entry data structure would be the following. Alright, so we arrive at the same place from where we began. Our root node enters into the initialized state again. Alright, so this completes the deletion of all the routes from this entry data structure. So I would suggest that you can rewind the lecture video and repeat and exercise the route deletion algorithm again. So far we have completed the route insertion, the route search, and route deletion. And what is left is the final thing, which is route lookup, which is based on longest prefix match. So this is the next and the final algorithm that we will going to discuss.